This video is recorded in the context of the INODE H2020 project that is funded by the European Commission. I'm Siham Ameriahia. I'm a CNRS research director in Grenoble in France, and I'm one of the partners in the project. The project has many use case providers, and today we have Sri with us, who is providing us with a use case for exploring very large data sets that represent galaxies. The purpose of today's recording is to present IDA for Some, a tool for summarizing these very large data sets. So first, let's hear from Sri. So Sri, can you introduce yourself?
Thanks for the invitation, Sihim. I'm Srividya Subramanian. I work at the Max Planck Institute for Extraterrestrial Physics in Garching, Germany.
Thank you. So tell me a little bit about your use case.
In this era of big data, the major problem faced by astronomers is the big data itself. And this big data astronomy is our use case now. We get enormous amount of data throughout the year, and these data are stored in databases after automated analysis. Developing the right set of tools to explore these databases efficiently is still upcoming in the field.
So how easy is it for you to navigate in the space of all this data, and why do we need new technologies?
Let's take an example of an astronomical survey called Sloan Digital Sky Survey, also called as SDSS. It has a huge database with hundreds of tables and about 800 million records with the data release version 16. Navigation through such databases itself without prior knowledge of the field or the knowledge of database programming language called SQL is impossible. What we need is an innovative method to access the data, which will let us explore in a top-down approach. For example, data exploration using machine learning, and also some sort of data summarization and support during the exploration process would be great to have. This will provide insights into the data, which is otherwise impossible to be derived using the traditional exploration processes.
So based on that, we're going to be presenting our tool that is indeed based on machine learning. Our tool encapsulates a number of operators that astronomers like Sri usually call or execute on the data. So the tool is called IDA for Some, and it iteratively, step by step, summarizes the very large data set that represents galaxies. I'm showing the screenshot of this tool, and what we're seeing here is a sets of galaxies that are described by a number of attributes that characterize these galaxies. Now, what Sri can do is select one of these sets, and then select the manual mode, exploration mode, and based on that, she may ask to dive into that set by exploring the facets of that set. So in this case, we see as an example one of the subsets of that set that has additional characteristics, and Sri may be interested in some of these galaxies that she would discover in a stepwise fashion. Other operators, such as the by superset operator, will allow her to look for supersets of these sets or sets containing these sets that then would lead to potentially some sets of interest on which she may choose to look for neighboring sets by selecting in a stepwise fashion another operator called by neighbors. I could pick another set and also ask for, in the space of all possible galaxies, what other sets of galaxies share similar data distributions with this set of interest. At each step, the system is going to be returning summaries, data summaries, that characterize all the results of the operator that Sri has evoked. At the top of the screen, we can see a recording of the pipeline, of the exploration pipeline, that has led to summaries at each step. The system also relies on reinforcement learning to learn a series of exploration operators that yield the best summaries. Sri may choose to just watch the execution of these operators, and whenever she is interested in one of the results, she could request to stop the exploration, go back into a partially guided mode where she can intervene and decide if she's interested or not in a result and potentially choose to execute other operators. So based on that, Sri, I'm going to ask you to give us some feedback on the use of this system. In particular, the first question is, what is your perceived usability and perceived control while using such a tool?
Combining summarization and various filters for data exploration together with visualization of galaxies, I find it really interesting, and it's very easy to understand as well. I really appreciate the way it's been implemented, in which the user is allowed to take either full control over the exploration process in a manual mode or partially guided mode where you get more support, and or to intervene in the fully guided mode.
Thank you, Sri. So what is also your perception of the required effort, or what is your perception of the temporal or mental demand that this tool requires from you?
With traditional exploration processes using SQL servers, the process happens like in a black box. You don't understand much. I feel Edu4Sum is mentally less demanding, while you see data exploration process step by step, and for a better understanding of the exploration processes. Time taken for each process depends entirely on your motivation, but if we can improve this technology, it can be really time efficient as well.
Yeah, and finally, what is your feeling of accomplishment? In other terms, how satisfied are you with the completeness of the summaries that are returned at each step?
Yeah, so to say, feeling of accomplishment requires a good knowledge of the field. The system indeed is an innovative start, and we derive really interesting results which can be taken further as an input for scientific studies. If we can include, for example, more essential attributes from the tables, and then we can make this process very effective and efficient.
So thank you for your feedback, Sri. There is room for improvement. INODE is a tool that is available for use through an application, but also the code is available on GitHub, and we hope that this has been useful to all of you.